Okay, look, the topic for today is parametric equations. You are studying how to represent a curve of the xy plane simply using an equation with two variables, x and y. For example, y equal 4x minus 6. These expressions is the expression, the equation of the line, and you use this expression in two variables, x and y, in the plane, in the xy plane, to represent graphically this line. But what happened now when I use parametric equations? In the parametric equations, in this lesson, you will learn to graphically represent the same functions using two equations, but introducing a third variable. For example, x equals negative 2t plus 1, and y equals 3t squared minus 2t plus 1. Now, if you see in this situation, I have two equations to represent the curve corresponding to the value x and y. I'm going to show you now how to use Desmos software to represent this function. For example, let me write this one. I have in the exercise, in the example, this is an example, x equals negative 2t plus 1, and y equals 3t squared minus 2t plus 1. And the x is negative 2t plus 1. And the y is 3t squared minus 2t plus 1. Okay? And now the value of the t now in this case is between 0 and 1. I want to give you more value. For example, between negative 10 and 10, for example. This is the equation of the parabola. Using the parametric, in this case the parametric expression, the parametric equation, using x and y, two variables, and the third variable t, and I can represent the parabola using parametric equations. Now I'm going to show you the definition. What is the parametric equation? If you have two functions f and g, and they are continuous functions of t in the interval I, then in our example, this expression here, this is the function f, this is the function g, t is the variable, and the interval is between negative 10 and 10. Now, the order period ft and gt, you see here, this is ft and this is gt, represent the parametric curve, and the equation x equals f and t and y equals g and t are parametric equation f of this curve. T is a parameter and I is the parameter interval. This is another example. If I want to represent this example, I'm going now to represent this example using the software Desmos. I'm going to do now. I'm going to change here. Let me move this. The new function. A new function is t squared plus 5t minus 2, that's the x, you remember? This is x, t squared plus 5t minus 2, and a y is t over 2. Close. Oh, that's a mistake. And the y is t divided by 2. And I close the parenthesis, and the interval is between negative 5 and 5. Now my interval is between negative 5 and 5. This is another relation. And this is the graph of this. This is the graph of this parametric relation. Okay? Now, continue now here. Another example. This example is sketch the curve given by each pair of parametric equation over the given interval. Now, I need to represent graphically. I give you two functions represented by t squared plus 5, and y is t divided by 2 plus 4, and the interval is negative 4 to 4, and I need to represent, sketch the curve of this one. You create a table between negative 4 and 4, negative 4, negative 3, that's the value of dt. You evaluate in t, in x, you evaluate, you select, you evaluate this function, using this function, you find this column, substitute t by this value. You substitute t by this value here, and you find it's 21. And you do the same thing, you substitute t in the y, and you find another value. And when you find, you plug in on the graph. For example, when it is negative 4, when t is negative 4, x is 21, you have 21 here, and a y is 2, and you get a 2 here. 21, 2. And you have here, when x is negative 3, I have 14, this is 14, and a y is 2.5, it's here, 2.5. Now this is, you plug in here, and this is this point. And now creating the table, when the value of dt is the corresponding interval, you plug in the expression of the x, you plug in the expression of the y, and you find the coordinates point, you plug in, and you create the curve. Another example. In this example, the question is not graphically, is write in rectangular form. What do you have to do? Number one, to eliminate the parameter t, I select this equation. To eliminate the parameter t, to eliminate the parameter 3, I need to solve this equation for t. Then you multiply by 2 and you solve for t. You leave t alone when you multiply by 2. And now you substitute the value of t, this value of t, you find it here. You substitute now in this equation. Now, because t is 2y, you get this 2y and you substitute here. Okay? And now 2y squared is 4y squared. And now you move 4y to the left side, with adding, you move subtracting, and 5 equal, and you create the equation in rectangular form. Then the method is solve, select one equation, solve for t, and substitute in another equation. Another example. In this case, it's very important to recognize that the value of t is not defined when x is 0 or negative, because you cannot find the square root of the negative number, and when t is 0, square root 0, and 1 over 0 is undefined. That's the reason it's rectangular with domain restriction. The domain now do not include t. T can be different than 0, and t had to be greater than 0, because here t had to be greater than 0. And you do the same. You select this one, you solve for t, you elevate to square to eliminate the square root here, and now you move this t to the other side, multiply, and now after that you divide by x squared and you get a t. And now when you find t, you substitute the value of t in this equation. You substitute in this equation. Substitute in this equation. Now 1 over x squared is substitute here. Okay? Now, do the operation, common denominator, and at the end, this is the equation in rectangular form. But remember, the curve is only defined when t is greater than 0. Then, from the parametric equation, this one, t had to be positive and t had to be different of 0. Now, the answer is x squared plus 1 when x is positive. Because if t is greater than 0, 1 over the square root t is greater than 0. Now, this x is greater than 0. Another example. In this example, you see I have now trigonometric functions. Trigonometric function. And I need to do the parametrizations expressed in rectangular, right in rectangular form when you have, this case is trigonometric function. In this case, you need to remember this identity. And you have to use this identity, you need to use all the time. Remember, don't forget it, you have to use it. Now, I select here, and you select each equation, and you solve for cos theta. Now, you leave cos of theta, and you do the same thing in another equation. You divide by 2 here, and another you divide by 4. And now, with this, you substitute here, and now you substitute here. Now, when you substitute now, you substitute there, you have, let me erase this one, because this interrupts me here. Let me erase here. Okay, now, you substitute x over 2 in cosine, you substitute cosine by x over 2 to square. And now, x squared, 2 squared is 4, y squared is y squared, 4 squared is 16. And you need to recognize what kind of conic is this one. This is an ellipse. This equation represents an ellipse. Center 0, 0. The vertex 0, 4 and 0, negative 4. And the co-vertices 2, 0 and 0, 2. And you make a graph. Because you see, because a squared is 16 and b squared is 4, a is 4 and b is 2. The center 0, 0. That's a vertical orientation because the a squared is in the denominator that have y. Vertical orientation. From the center is 0, 0. You move 4 units up. Is 1, 2, 3, 4. And down. 1, 2, 3, 4. Because that's the value of the a. And to the left, 1 and 2 because it's b. And a 1 and 2 to the right. And now you can create a graph. I want to show you in the Desmos square, some of the function, interesting function. For example, suppose I have now using this kind of problem when you have the trigonometric function, for example. You have in the x is sine of t and y is cosine of t between, what is the graph of this? This is a circle. We're going to find that between t is between 0 and 2 pi. I'm going to say 0 to pi. Sorry, 0 and 2 pi. This is the circle. And the radius of the circle, in this case, 1. What happens if I change here and I write here 2? Oh, it's a horizontal ellipse. If I change now and I write here 2 here, it's a vertical ellipse. And now, what happens if I introduce another variable here, t? Oh, it's a different function. And if I introduce another variable here, oh, it's very interesting. Now, using the parametric function and the trigonometric function, you can find very interesting parametric graph. Thank you very much to watch this video, and I will see you in another class. Thank you very much. And before to finish, and I forget this example. I think that this example is very important for you. And the problem is write the equation in a parametric. Write the parametric equation. And I give you in rectangular form. The first example, you change x by t. Substitute x is equal to t. You substitute t on the equation, and that's it. Another example. I give you what is the value of t. The same equation. I continue with this equation. I continue with this one. But now the x, the parameters, the equation of the variable t change. Solve for x, you solve for x, this one, you solve for x, and substitute in this one, substitute, and finally you have the parametric representation. Okay?